Lipidome dynamics in an ovarian cancer mouse model. I should start by saying that ovarian cancer is one of the most common and deadly cancers in women worldwide. 1 in 78 women are at the risk of developing ovarian cancer during their lifetime, and 1 in 108 women has a lifetime chance of dying from ovarian cancer. This is particularly the case because ovarian cancer is asymptomatic at early stages when it's most curable, and it presents itself with vague symptoms in later stages. So it's not surprising that patients are typically diagnosed incidentally and late. A primary goal of this research is to understand the lipidomic, the metabolic dynamics of the disease, with the ultimate goal of discovering biomarkers for the detection. DICER P10 double knockout, what I'll be calling the DKO mouse, is what we use to really study the human high-grade serous ovarian cancer, and we're studying this particular subtype because it's the most common and deadliest subtype of ovarian cancer. It arises from the fallopian tube, and of course the DKO mice has clinical and molecular phenotypic similarities with this subtype of ovarian cancer. For the methods, I've introduced the DKO mice. We have a DKO mice control. Blood samples were collected longitudinally, and lipid identification was actually conducted using liquid chromatography mass spectrometry. And our methods, our research themes now, actually comes in 3 important folds. First, we want to study the global lipid changes. What are the longitudinal trends of the lipids? How does it change over time? And what are the ovarian cancer lipidomic signature? These concerted analyses actually led us to actually discover some discriminative lipid classes, which I will be discussing now. Early progression of ovarian cancer is marked by increase in number in the levels of phosphatidylcholines and phosphatidylethanamides. And these are phospholipids. They are important in cellular membrane stability. And of course, the species of these lipid classes would be important candidates for early diagnosis. Later stages are marked by more diverse lipid alterations, importantly ceramides and exoceramides, because they are important in cellular survival and proliferation. So in summary, lipidome-like dynamics provide us with the evidence of perturbations in cell membrane stability, cellular proliferation, and survival. And in fact, now importantly, we now have lipid candidates that we will use to interrogate early diagnosis of ovarian cancer for our future human studies, which will be starting in earnest. Thank you for listening.